Hey everyone, so I did not assign this video to you guys in class when we last saw each other on Friday afternoon or Friday morning, I guess, but this was sort of a spur of the moment thing that I thought I should put together in preparation for what we're going to do over the next couple of days. So in class we discussed that the next error analysis or uncertainty analysis that we want to conduct is from a range of measurements of the same sort of material. In this case, we're looking at the density of the rubber stoppers that you measured in class on Friday. You didn't all measure exactly the same rubber stoppers, so that means we have to do our analysis of that data and our analysis of the uncertainty a little bit differently. So what I'm going to do first is I'm going to put in just a set of data. This is completely made up numbers that I just came up with real quick on the fly. It doesn't mean anything at this point, but in this case here, I'm going to go 11, 21, 32, 39, 51, and 59 in this spot here. And then in column B, I'm going to go 12, I'm going to go 18, 29, 42, 50, and then 59. You'll notice here that I've just put some values in. I haven't put in any absolute uncertainties. I had you guys measure those absolute uncertainties when you were measuring your mass and volume values. Those will come in later on. Right now I'm just looking at the measured values. In this case, it would be one certain value or one certain digit, one uncertain digit. So not real precise on these measurements, but this is just an example. One thing I also forgot to say, notice that I am using Excel. I have really tried to do these operations in Google Sheets. I have looked online, I have messed around with it myself, and I really just cannot find a way for Google Sheets to do all the things that I need you to do for this graphical analysis. So we're going to have to work in Excel. I know Excel is a Microsoft product and all the kind of good stuff, and it's not free and it's not online, but it really does a better job than Google Sheets does, so that's why I'm using it. First thing I'm going to do is I'm going to make a graph. So I'm going to highlight the numbers that I've inputted, the measurements that I've inputted. I'm going to go up here to the Insert tab, and in the middle here in the section that says Charts, we have a whole bunch of different options. We're going to make scatter plots because those plot one set of data against another set of data. I'm going to use the drop-down box, and I'm going to pick the scatter plot that just has the points that of those data points, no connections, no smooth lines, no rough lines, just the points of the data that's there. I hit the button there and it makes my chart for me. Now, there's a lot of things missing from this chart. Some of them are generically showing up, but others we're going to have to look for a little bit. So up at the top, chart title, you can go into this box, you can print something, so you might want to say like mass versus volume for rubber stoppers, or whatever it is that you are graphing. Then if you click anywhere on this chart that isn't in a text box, you get these three boxes over here on the side. The one that has the plus, and so if you hover over it, it says chart elements, that's the one that we're going to use the most for this activity. So I'm going to hit that button. You'll see that some of them are automatically checked, like axes and chart title and stuff like that. So real quick here, if I click axis titles, I can, you'll see that the text boxes show up on the graph automatically, and then we can go in and do this. We're gonna, if this is indeed the density activity that I'm going to have you guys do here, mass would be on the y-axis, volume would be on the mass would be on the y-axis, volume would be on the x-axis. That's going to be important later on when we start interpreting data. So real quick, we can do that there. Alright, so now let's talk about some other things. We use charts to find trends. We use charts to look for patterns in a visual way that's maybe a little easier to see than when we just have like a data set, like the 6 blocks of numbers up here on the top. So I'm going to hit the plus button, and I'm going to go down here to trend line. Now, trend line is not checked right here, and if I hover over it, I haven't clicked anything yet, it puts in a generic trend line, which is fine, but we're going to want a little bit more detail. So instead of just clicking that box, I'm going to use this little arrow on the side over here, click it, and then it gives me a couple of trend lines that are popular but the one down at the bottom that says more options allows me to do more detailed things. So I'm going to click that option, and over here on the side, say format trend line up at the top, and then it has trend line options. So here, this is the paint can gives you the actual formatting of the trend line. So right here, it sort of automatically puts in this dashed version of the dots, 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 round dots, whatever. I really don't care. I'm going to keep it round dot just because they made it that way to begin with. But I'm more concerned about this one, the one that kind of looks like a graph over here, and if you hover over it, it says trend line options. So I'm going to click that one. Excel will automatically put a linear trend line in, but we can change that if we need to. We can make exponential or logarithmic or polynomial. Sometimes certain sets of data lend themselves better to trend curves than they do trend lines. Depends on the mathematical equation that's being modeled. This one's pretty straightforward. Obviously, I made some of this data not perfect because I wanted it to be representative of stuff we might find in the real world. So you'll see that some of our dots are above the line, some of our dots are below the line, but for the most part, it's pretty linear. So I'm going to keep that bullet clicked right there. All right, next one, trend line name. It automatically calls it linear series 1 because it's representing that data. I'm actually going to change that to measured data, and you'll see why in just a second after I add a couple more lines to this graph. So I'm going to call mine measured data. Next one down says forecast. Automatically, Excel just sort of starts it at the first dot and ends it at the last dot. But if I want to extend that a little bit more, I'm going to maybe go 5 periods. A period is basically a unit on the x-axis, so that'll extend it a little bit more past the last data point. And I'm going to go backwards about 11 periods actually, because that should take me right back to where the graph starts, and you'll see that that sort of here, that gets us back to like very close to the origin. It adds actually a negative value just because it's trying to be inclusive of all the data points. That's not a big deal for me. Then 2 more boxes I want you to click. One says display equation on chart. One says display R² value on chart. So I hope you guys realize by now that any line, whether it's a trend line on a graph or a line that we draw in math class, has a general form of y equals mx plus b, where m represents the slope and b represents the y-intercept. This is a straight line. It has a general equation of y equals mx plus b, which when I clicked the value, oh, that's not what I wanted. Oh, I know what happened. Never mind. Going back here, when I click that box, it finds the equation of that line that it drew as the best fit of the data. R² is another statistical measure of how well the data fits to the line that's been drawn. So you see here that there's an R² value of 0.9841. The closer the R² value is to 1.0, the better the data fits. So here we're pretty good, but there's definitely some deviation off of that line, and that's reflected by this value of being 0.98. Okay, we've got a trend line showing us the trend in the data, but we want to show from an uncertainty standpoint how well we're actually fitting that data. R² is fine, but we can also visually represent that as well. So I'm going to go back over here. I'm going to exit the format trend line window over on the right hand side. I'm going to click the box again, and I'm going to go here to error bars. Now when I hover over error bars, again I haven't clicked anything, when I hover over error bars it automatically puts some in as a sort of a default setting, but again if we use this little arrow over here on the side, it gives us a couple of different options: percentage, standard error, standard deviation. I'm going to go to more options just so I get what I want. Here's where the absolute uncertainty of your measurements comes in. The error bars on a graph represent the absolute or they represent the uncertainty. In this case, I want them to represent the absolute uncertainty. So let's say that we had a measuring device that was like the large graduated cylinders in class, had lines on it that represented 10 milliliters or 10 grams. Not real precise measurements, but it makes our job for this graph a little bit easier. We talked about the idea that if the divisions are 10 milliliters, our absolute uncertainty is going to be plus or minus half of the smallest division. The smallest division is 10, and that means the absolute uncertainty is plus or minus 5. So over here on the side, up at the top, it gives us some options as far as what we want our error bars to look like. You know, do we want just one? Do we want both top and bottom? Do we want it line at the end or capped at the end? Whatever. I'm more concerned about this section here that says error amount. So here we can talk about percentage uncertainty or standard deviation. Okay, we didn't talk about that in class, but we're going to go with a fixed value. A fixed value would be an uncertainty that is representative of the absolute uncertainty. So here they have a fixed value of 1. But I kind of mentioned, like, if we're doing something representative or that is similar to the graduated cylinders in class, our absolute uncertainties were plus or minus 5. So I'm going to change that fixed value from 1.0 to 5. And eventually, when I click off of it over here, we'll see that the Y error bars have gotten themselves much larger than the X error bars. Now, I'm going to go here, I'm going to click that. Oh, that's not what I wanted to do. I'm going to go back here, I'm going to go to error bars, I'm going to go back to more options. So error bar options up here at the top, Excel kind of defaults to the y-axis because usually that's the one where the error is most associated. But if you see in this drop-down box, we can also adjust the X error bars. So I'm going to do that here. And not that this is always the case because you, like on your graph, you use 2 different measuring devices to measure the X values on this chart and the Y values on this chart. But just to make my life a little easier and make this video go a little faster, I'm going to go back down here to fixed value and I'm going to make that 5 as well. And when I click off of there, now the error bars have extended 5 in both the X and the Y direction. Now they don't look exactly the same just because on Excel the y-axis and the x-axis aren't scaled the same. So 5 on the x-axis is going to take up a little bit more room on our graph than 5 on the y-axis. No biggie, obviously it doesn't look symmetrical even though both of them are 5, but it's getting what we want to get at. Okay, now here's where we have to start analyzing the uncertainty in this graph. We see that at this point, unless I'm mistaken, no, it's good, the trend line falls through all, or the trend line is within the error bars of all 6 points on this graph. That's good, because that means that our error bars are encompassing what we believe to be all of the possible values, and our trend line falls within those ranges. That's good. But being that that is a range, it means that we have more possibilities than what we're showing with this trend line currently on the graph. For instance, if we take a look at this data point up here on the top, by saying that we have error bars extending X and Y, that this point that is currently labeled as Series 1, Trend Line 1, let's move it a little bit and see if I can get the actual point. Of course, it's not going to do it for me, but that's okay. So anyway, this point here, and it still says trend line, whatever. So that this data point that we've graphed, in theory, could be all the way up here, where my little double-sided arrow cursor currently is. If the X value was as low as it possibly could be, and the Y value was as high as it possibly could be, that data point could theoretically be at the point that I currently have my cursor. But it also could be way down here in the bottom right-hand corner of what would essentially become a rectangle on this graph. Because if the X value was as high as it could possibly be according to our absolute uncertainty, and the Y value was as low as it possibly could be according to that absolute uncertainty, that's where the data point would fall. Now, that leaves a lot of room for the tilt of our trend line, because our trend line could, as long as it fits within those error bars, be steep or shallow or all kinds of things. So here's what I'm going to do. I am going to take this first data point that I've labeled as 1112, which would be this point on the graph right here, stating that my absolute uncertainty was plus or minus 5. The X value, the lowest possible X value for this point, could be as low as 6, because 11 minus 5 is 6. Now that would put me over here in where that error bar is, where my arrow cursor is right now, but my y value could be as high as 17. That's the plus 5 on the y-axis absolute uncertainty. So this data point, even though it's currently showing up on this map, or on this graph at this point according to our measurements, it could be way over here. Now, I'm going to go to this data point over here. We kind of established that this data point could fall anywhere here. The highest possible x value that this data point could have would be 64. That would be 59 plus 5 on the x-axis. But the lowest possible y value it could have would be 54, because that's y value minus 5. So these four numbers right here, I'm going to use actually to make another line on this graph. This is the part where Google Sheets really just doesn't work as well. So what I'm going to do is I'm going to right-click this graph, and I'm going to click this, or I'm going to select this option that says Select Data. So here we have one series already on this graph, and I'm going to edit that series, and instead of just calling it generically Series 1, I'm going to call it Measurements. So all that did was just change the name of my that data set. But now I'm going to add a data set. So here I'm going to call this shallowest slope, and you'll see why in just a second. Then here it has two fields where you can select what you want to be the x values of this data set and what you want to be the y values. So I'm going to go here and I'm going to highlight these two values, values in A9 and A10, to be my x values. And then I'm going to come in here. I'm going to delete this little bracket 1, because if you don't, it just kind of messes the graph up. But then I'm going to select these two values to be my y-axis. I'm going to hit OK, and I'm going to hit OK again, and you'll see that it put two more data points on the graph. Different color, that's important, and that's going to be a new set of data that's on our graph. Now, what I'm going to do is, but just like before, even though these are two new sets of data, they theoretically could be a possible measurement of this data point according to the error bars or the absolute uncertainty that we've selected. So what I'm going to do is I'm going to click on this orange dot, okay, and it highlights these squares over here. That's fine. But then I'm going to go over here and I'm going to add another trend line. But now, because I've added a new set of data onto my graph, I'm going to go over here, hit the arrow, hit more options. This is still going to be a linear trend line, which is fine. I'm going to click the equation on chart, display the r squared value again, move that over here just to get it out of the way, and you'll see that we now have a new line that has a different slope than the one that we originally put on. And hopefully you're paying attention, but that slope is much shallower than the one that I originally put on the graph. So according to our error bars, the absolute uncertainties that we've selected for this set of data, even though blue is our best guess, the trend line here could have a slope as shallow as the orange line that's on that graph. Alright, now I'm going to go the other direction. So this orange dot here represents the plus or minus of this original data point on the x and y axis. I'm going to go to the far other corner. To do that, I would have to add 5 to my x value. So the x value of this possibly could be as high as 16, but then we have to go the opposite direction on the y-axis, so the y value could be as low as 7. All I did was add 5 to 11 to get to 16 and subtract 5 from 12 to get 7. Same thing up here. I'm going to subtract 5 from 59 to get 54, and then I'm going to add 5 to 59 to get up to the top corner of what would be a rectangle that encloses these error bars, and that would be 64. So again, I'm going to come to my chart, right click, select data. Now I have two sets of data on the graph. One is measurements, one is shallowest slope. I'm going to add a third set of data. I'm going to call this steepest slope. X values are going to be these two X values that I just calculated for those two new data points. I'm going to go in, I'm going to delete bracket Y. I'm going to highlight these two values to be my Y coordinates of that new line. I'm going to hit OK. I'm going to hit OK again, and you'll see that it put two new dots on that line, different color. That's important because it's a new set of data. I'm going to click on those right there. I'm going to, just for the sake of this video, call these, or make these a little bit different instead of making them gray. That's pretty boring. We got blue, we got orange. Why don't we make this one green? I'm going to come over here and make this green. This is completely not necessary, but just to make it stand out a little bit different. Okay. So then I'm going to click on those dots again. I'm going to click the plus sign. Notice trend line is unchecked because we don't have a trend line for these two positions, but I'm going to put one in there. I'm going to hit the arrow. I'm going to go to more options. I still want, click this one up here. I still want it to be a linear trend line. I'm going to put the equation on. I'm going to put the r squared value on. I'm going to slide this over here. I'm going to get rid of the box. And now we have added two new lines that represent what could be the possibly steepest slope of this graph or the shallowest slope of this graph based on the error bars that come from the absolute uncertainties that we've selected for our graph. This is how we do the uncertainty analysis of a graph, by looking at, okay, what is the trend line that we've drawn versus what could it be based on the high end of those absolute uncertainties, and what could it be on the low end of those absolute uncertainties. So that's an overview of how we're going to make these graphs in class. I'm going to go over it in class again. I'll help you guys with it, but it might be good for you to get a head start on it by taking a look at the video before class on Monday, or maybe in between class on Monday and Tuesday, and that will help you with this analysis. We'll talk about what the numbers mean and what that means for our analysis more so in class.